Students, in last class you have studied the diversion canal hydroelectric power plants. In this class you will be studying high head diversion power plant. Such type of hydroelectric power plants are constructed when a main river flow is at certain good height, say in hilly area. From the main river the water is diverted by means of a tunnel to a surge tank, and from there the water is supplied to hydroelectric power plant. So let us see how such plants appear. Say it is main river flowing in some hilly area. And you can see that the river is taking a turn here. You can call it as U-turn. From this main river, you call it as main river here. Water is diverted by means of tunnel. So this is tunnel here. And we will show one surge tank here. I will explain you what is surge tank very soon. Now this is penstock. This is surge tank. what you are seeing here is turbine and generator arrangement. Turbine and generator are placed in powerhouse. The water that comes out of turbine once again flows back into the river here. The water that comes out of turbine is called as tail race. It is called as tail race. Here is powerhouse. The penstock is supported here by concrete structure. Yes. If required here, one forebay may be constructed. Now, the water that is diverted will enter into surge tank here, and from the surge tank water flows into turbine through a penstock. So here is penstock. This is powerhouse. The water that enters into the powerhouse will rotate the turbine. Since the turbine is coupled to generator, the generator will generate electrical power, and that power will be fed to the load. So here what you can see is three-phase line. In case of high head power plants, surge tanks are constructed. The reason for constructing surge tank is that if all of a sudden the load on the power station decreases, that means electrical load is disconnected, then the generator needs less water for power generation. So there will be a governor, speed governor, and that speed governor I have not shown here because it will make the figure very much complicated. That speed governor will control the inlet valve for the turbine. That means the inlet valve will close partially. When the inlet valve closes partially, then the pressure in this penstock will increase. Because of that, the penstock starts to vibrate. The vibration of penstock, because of sudden reduction in water flow through it and the backflow of water, is called as water hammering. If water hammering happens to be there continuously, then the penstock will be damaged. The penstock will be broken mechanically. So in order to avoid that, a surge tank is constructed. So it is like a shock absorber. When water flow all of a sudden reduces in the penstock, the water level in the surge tank will rise. The water level in the surge tank will rise, and that will reduce the pressure and vibration in the penstock. So penstock will be safeguarded against water hammering. After the water flows out of the turbine, that gets into the same river, or if there are any other rivers, then into that river also this water may be discharged. In case of high head diversion, power plant, the water from main river diverted through the tunnel. This diverted water is utilized. This diverted water is utilized for power generation. In case of high head power plants, surge tank is constructed. The surge tank behaves like a shock absorber for the penstock. When load on, power plant increases or decreases. Then the speed of generator decreases or increases. To maintain the speed constant, and hence the frequency of generated EMF constant, speed governor opens and closes the wall at the end of the penstock. This causes sudden change in flow of water through penstock. This results in water hammering. The water hammering may cause damage to the penstock. If surge tank is constructed, it makes effect of water hammering less by supplying water when load increases and taking water when load decreases. The water coming out of turbine may be discharged into the same river or any other river nearby. This water flowing from turbine to the river is called tail race. A forebay may be constructed if necessary to generate power continuously near diversion point. A typical high head power plant and its components. First, let us see how these power plants appear. Say here is a reservoir and a dam is constructed. To create a pondage. Here is an underground tunnel that you can see, and this underground tunnel is connected to a surge tank. Every high head power plant will be having surge tank. That's what you have to remember. From surge tank, a penstock runs towards turbine. This is turbine and generator. And here we will show the powerhouse. Here I will show a three-phase line. These three-phase lines are coming from generator. The water coming out of turbine, as you all know, is tail race. Support to the penstock. This is dam here. Water behind the dam. We call it as pondage. Surge tank. There is some hill here to show that it is underground tunnel. Penstock. Powerhouse. Some more components like generator and turbine are to be studied, and that we will take up in next class. This high head power plant is having most of the parts or components which you have studied already. That is powerhouse, penstock, surge tank you have studied, dam you have studied, reservoir you have studied, tunnel you have studied. Only we are now left with generator and turbine, and about generator and turbine we will study in next class. Thank you.